Right, so what have we got here? Well, it looks like a circle with some lines and a triangle, in fact. No angles or anything. So let's read the question and put in any information we can find. So A and B are points on a circle, centre O. All right, nothing to do there. BC is a tangent to the circle, and we should already be thinking things like a radius and a tangent meet at right angles. Okay, just a thought to have. There are other things to do with tangents, but that's the sort of the obvious one. Right, AOC is the next thing. That's a straight line. Okay. ABO is equal to X. Now, they haven't even given us ABO as an angle, so let's mark it in. ABO, that's X. And while I'm there, I've just drawn a radius. And we've just remembered that a radius and a tangent meet at right angles, so let's put that in as well. Okay. Find the size of angle ACB. Right, which one's ACB? That is this one down here, the very sharp angle at the right-hand end there. And we're asked to find that in terms of X, giving our answer in its simplest form and giving reasons. Well, let's just do some playing on the diagram first. What else do I know? Okay, well, starting with X, look, I've got an isosceles triangle there. So my other angle here, OAB, is also X. So let's write that down. So AOB is equal to X. Why? Because we have an isosceles triangle. So I'm putting down my deductions as I go. How does that help? Well, that allows me to find this angle in here, AOB. It's a triangle, so that angle there is 180 minus 2x. So let's write that down. AOB is 180 minus 2x, and that's just because of the angles in a triangle. I could possibly have combined those last two and just gone straight for that, but it's good to be clear. What happens next? Well, looking at my diagram, now that I can see it again, I've got a straight line here, and so BOC adds up with AOB, which is this one, to give me 180. So BOC must just be 2x, so that when I add those two together, I get 180. So let's write that down. Okay, BOC is therefore 2x, and we can say that's angles on a straight line. And then, finally, well, I've now got two angles in this triangle here, OBC, and if I've got two angles in it, I can find the third angle, which is the one I want. So, BCO, which is what I want, or BCA, in fact, let's call it. In fact, let's call it ACB, because that's what they call it. It's still all the same angle. It's that angle there. So ACB is, well, we know that OBC is a right angle, so the rest of it must just be 90 minus 2x. And I do need to say that OBC is a right angle. Okay, why? As the radius and tangent meet at 90 degrees. Now I know I've said that further up, but let's just make it absolutely clear what I'm doing. Okay, so meet at 90 degrees, and there we go. Well, is that as simple as it can be? I think it probably is. And so we are done. And all I've done to do that is I've started with what they've given me and just done what you might call angle chasing until I've got the one I want. There we go.